Alright, today we are still on the tangent, translating, and reciprocal unit. We are doing lesson 3, which is the reciprocal trigonomic functions. Today's date is today. And our objective is to evaluate reciprocal trigonomic functions and to graph some reciprocal trigonomic functions. So let's go ahead, because I'm sure you guys are asking yourself, gosh, I wonder what reciprocal trig functions are. Well, let me show you. Cosecant, secant, and cotangent, and they are just the reciprocals of the ones that we have already known. Cosecant is 1 over sine, secant is 1 over cosine, and cotangent is 1 over tangent. That will be something I will expect you to have memorized for the test and lesson quizzes. So if I were going to match these, sine goes with cosecant, cosine goes with secant, and tangent goes with cotangent. One thing that sometimes helps me remember which one goes with which is when you pair them up, each pair only has one co. The sine goes with the cosecant. The cosine goes with the secant. And the tangent goes with the cotangent. You'll never have two prefixes of co that go together. All right, we are going to find these values without using a calculator. And I'll tell you right now, it's going to be easier is if you have your unit circle in front of you. So secant, that would be the same as 1 over cosine of 2 pi. Well, so I look at my unit circle. Right here is where I have 2 pi, because that would be 1 rotation around. Cosine is my x coordinate, so that would be 1 over 1, which is 1. Let's go ahead and do a couple more. Cosecant is 1 over the sine of 5 pi over 6. Well, I look and find where 5 pi over 6 is. And because I'm doing sine, I'm looking at my y coordinate. So that's going to be 1 over 1/2, which is 2. Let's do a cotangent. Well, I know tangent is 1 over, or is y over x. Cotangent is a reciprocal of that, so that's going to be x over y. So let's go ahead and find my pi over 3. Pi over 3 is right here. So that's going to give me 1/2 all over radical 3 over 2. Remember, dividing is like multiplying by the reciprocal. You're going to get 1 over radical 3. You need to rationalize that. And you're going to get radical 3 over 3 as your answer. Let's do a few more. Again, want to keep that unit circle handy. Cosecant is going to be 1 over sine. So I need to figure out what the sine of 7 pi over 4 is. So find 7 pi over 4 on your unit circle. That would be 1 over y, which is going to be 1 over, and my y here is negative, which is the same as 1 divided by So I end up with 2 over radical 2. We need to rationalize that. I get 2 radical 2 over 2, which is radical 2. Running out of room there. All right, let's go ahead and do a couple more. Secant is 1 over cosine, which would be 1 over x. So let's go ahead and find out where 4 pi over 3 is. My x-coordinate is negative 1/2. So I'm going to have 1 over negative 1/2, which is going to give me negative 2. Cotangent is x over y. So let's go ahead and figure out where pi over 4 is. And that will give me radical 2 over 2 all over radical 2 over 2, which is 1. All right, let's go ahead and practice how to put these into the calculator. I'm probably not going to do all of these because I'm assuming you guys can operate a calculator pretty easily. The main thing is you want to make sure you are in the correct mode. These first 3, you'll want to be in radians. The last 3, you want to make sure you're in degree mode. That's probably going to be the biggest mistake. So on the first one, if I did secant of 20, that's going to be 1 divided by cosine of 20. So let's go ahead and bring up my calculator. Turn it on. Make sure I'm in the correct mode, which, yeah, I'm in radians. And the way I would just do that then is 1 divided by cosine 20. And I get 2.45. For the next one, you would just do 1 divided by the sine of 3.4. And for cotangent, 1 divided by the tangent of negative 4. Let's go ahead and do one of the degrees. Let's do the cosecant of 62 degrees. Well, that would be 1 divided by the sine of 62. So bring out my calculator again. Just make sure that I'm in the correct mode, which I'm in radian. I need to be in degree this time. So now I'm in degree. It's just going to be 1 divided by the sine of 62. And I get 1.13. All right. Again, it's just a matter of plugging it into the calculator. Let's talk about graphing. All right. On this one, we've got a cosine graph, which I went ahead and converted everything into decimals, and a secant, where is going to be the inverse, 1 over cosine. If you notice, I've got a couple places that are undefined, because when cosine is 0, that means I would have 1 over 0, which is impossible. You're going to have an undefined graph because we can never have 0 in the denominator. So I'm going to go ahead and do my cosine graph, and I'm going to do that in just a real light gray because it's going to be something that you've already seen before. Cosine starts at max 0, min 0, max. There. So let's go ahead and graph that. So there's your cosine graph. Again, that's something that you've seen before from 0 to 2 pi. Let's go ahead and do the secant graph, and I'm going to do the secant graph in red. So think of these as ordered pairs. Here's our x value, here's our y value. So that would be 0, 1, pi over 6, comma, 1.2, pi over 3, comma 2, pi over 2, undefined. Well, if it's undefined, that's going to be a asymptote. So when I do the asymptote, I'm just going to kind of do it in a dotted line. Imagine that's a straight line. And if you notice, I'm going to have an asymptote every time that cosine graph crosses the x-axis. So I'm going to have two asymptotes right there. Let's go ahead and graph it at 0, 1. Pi, it's going to be 1.2, so slightly above. Pi over 6, it's 2. So what's happening is it's going to be going up, and it's going to approach that asymptote but not touch it. For the 2 pi over 3, my value is -2. Negative 1.2. Negative 1. Okay, that's not the best drawn. I'm going to extend those asymptotes down a little. What's happening there is it's going to look something like that. And then for the rest of my graph, at 5 pi over, oops, that should be a 3 there, I'm sorry. It's going to be 2. You're going to get a graph that's going to look like that. Not the best drawn, but you can kind of get an idea. For a sine graph and a cosecant, well, let's do those in straight lines. We've got pi over 2, pi, 3 pi over 2, and 2 pi. So if I were to sketch my sine graph, it would be 0, max, 0, min, 0. So that right there is sine. If I were going to do the cosecant of that, I'm going to have an asymptote right there. An asymptote right here. And an asymptote right here. And I can tell pretty easily that's where my asymptotes are because that's where my value is 0. And if I did the inverse of that, I would have 0 in the denominator, which is undefined. So I'm going to have a graph that's going to be touching right there. Go back up. Going back down. So that would be the cosecant. I'm going to go ahead and stop there. Hope you enjoyed.